Dear future Ken, sorry, regards, past Ken.
Aren't you present Ken right now?
Well, not anymore.
Sounds like a Spaceballs movie.
Dear past Ken, you jerk.
We're at now.
Yeah. Now, yeah. This is now.
Now.
Yeah. I don't want to go then. Welcome back to OT After Hours, a podcast about industrial cybersecurity, why it matters, and all of the challenges that it presents. We actually do have a few returning names on the podcast, and I'm again going to go left to right across my screen. We have Lance Lamont, Tyler Bergman, both back from episode 1, and also a couple of new voices, Andrew Wintermeyer and Doug Artz. So, Lance, why don't you say hello?
Of course. I was the person that everybody was hearing in the first episode, apparently. So I lead the research team at Verve Industrial Protection here, and we try and figure out how to talk with all sorts of cool devices. I've been involved in embedded devices for many, many years and love being part of that industry.
Alrighty. Tyler?
Hey, guys, once again. So, Tyler Bergman. Been working on stuff since 9-year-old on my TRS-80 and doing different consulting here and there for a while, working in utility profession for about 20 years in different capacities, from engineering design to now doing cybersecurity stuff. So pleasure to be here with you guys.
Brilliant. And yeah, like I said, new to the podcast, Andrew Wintermeyer.
Hey, my name's Andrew. Let's see, I am the research lab manager here at Verve. So I manage and maintain about 500 different OT assets. And yeah, just happy to be here. Thanks for having me.
Cool. Doug, is your iPhone working?
It is. Can everyone hear me?
Hey, there you are.
Great.
That's Doug.
Hey,
right.
Thank you. I appreciate the patience, guys.
No worries. Why don't you give us an intro blurb, and then I'll go back to rambling.
Absolutely. So I am coming to close to a decade now working in the OT space, OT cybersecurity. Worked on everything from design, implementation, mainly focusing on the power plants, nuclear power plants, and wastewater treatment facilities.
Brilliant. I'm Kenneth Cully. I guess I used to call myself a cyber team lead, but since the last episode, my role's changed a little bit. Now I'm the operations support lead with Verve, and the host of the podcast. And, you know, kind of like Tyler, I've been doing this for a long time, and it just has kind of always seemed that my career through engineering kept me in the orbit of OT, and I'm doing OT cybersecurity. So that's pretty cool. And on that note, as promised last...
Isn't that a segue?
Yeah, well, how many wheels is on a Segway? Because that one only has one. Two. There we go. Okay. Right. So I saw a person riding the whatever the one-wheeled one is, like the little motorized unicycle, but not like an actual, like with a seat, just the wheel with like platforms on either side. I forget what those are called.
Kind of like a one-wheeled skateboard or something?
Yeah, I don't know.
I think they're mono wheels.
Yeah. Okay. Good to know. I don't know electric scooters or anything like that. It's not really my scene. Just throw me on a bicycle.
I keep falling off.
But as mentioned in the previous episode, the second episode was, I wanted to focus on kind of a question of what is OT? Because we throw around terms like OT and a parallel term, ICS. OT stands for operational technology and ICS stands for industrial control systems. Although, funnily enough, industrial cybersecurity also abbreviates to ICS, but that's neither here nor there. We mention these terms a lot, and I mean, most of us just kind of fall into the habit of, you know, just using the acronyms because we deal with it so much every day. It's just kind of part of our lexicon now. But my goodness, getting an actual definition of what this stuff is kind of a challenge. We have these terms, OT, ICS, and if you've dealt with them at all, you can probably intuit that they're not, you know, OT has, I think, kind of come to the forefront because it parallels IT. And we know, most of us, I think, hopefully all of you out there listening have a decent sense of what IT is beyond just, they're the guys who tell me I can't do that all the time with my computer. But, you know, like we kind of grasp, I think now, and it's become pretty apparent, the role of IT, of information technology, and that group within a company. They're the ones who are in charge of maintaining the fleet of hardware, servers, laptops, desktops, the operating systems that run thereupon, updates for those. If there's antivirus in play, that's usually their responsibility as well. Software updates of various sorts, providing software, but also things like, data management, data confidentiality. We talked about some of that last time as well, the CIA triangle, maintaining connectivity because IT is almost always internet facing. And so if we think of OT as like a parallel to IT, we can intuit that some of those roles probably cross over. But at the same time, OT is kind of a different beast. We can kind of grasp that because it's a different environment. The requirements are different. The constraints are different. The challenges are different. But even so, what is OT?
Yeah, so don't forget the SCADA systems out there too. You got ICS, DCS, SCADA, all kinds of different terminologies out there, right? So I think it breaks it down into, some of the major aspects of it when I look at it across the board, it's just, consolidated systems that are controlling some type of a process or something of that nature out there, right? Something that's, manipulating the physical world as far as a process or something of that nature. And I think that's I've done some soul searching there for a while, and I think that's what it really kind of consolidates it down into like a singular set. Is something that's controlling the process in the physical world, has real world impact as far as moving parts of machinery, things of that nature. And it just seems to be a little bit more broader of a brushstroke across the board because, you can have, manufacturing, you can have industrial processes, you can also have wide area processes that are going on for like a SCADA system within a utility environment. Electrical mechanical style devices in the forms of protective relays in the electrical system for controlling energy usage and things of that nature out there as well. So it has real world large impact instead of like on the IT world. Where it may be an individual machine or server. And I don't negate the overall scope of those systems, but typically, you have individual user stations that if they go down, they only impact like one person. Whereas if you have a station go down for like an operator, it has, could be major impact for that operator. And they do have redundancies in those natures for multiple different workstations that they're at to make sure that they maintain visibility. But you have reduced functionality set when it comes into those that have impact in the real world aspect that's out there. So I think that's kind of what it really boils down to me. You've got the IT side, you have servers out there. Typically, if you've got like large email facilities out there, you have a lot of redundancy built in to where if you do lose like a single server and like a server farm for email structures and things like that, you'll have a little bit of a reduced capacity. But a lot of times they try to design those to where it's a lot less impactful on those. Whereas on the OT side, there's a lot of other considerations that go into it. They do have redundancy built into it on a lot of cases, but it just really depends on where they are in their venture as far as, from an operational standpoint. And that's not even talking to the next bridge over of the cybersecurity standpoint where your positioning is there as well.
Tyler, I have a quick question. When you said operator, what did you mean by an operator?
So I really stereotypically go towards like a control room, right?
Okay.
So let's talk about like a energy production facility. So you have a control room. You have an operator there that's monitoring the processes, the little dials and gauges and things of that nature, to make sure that something that is not going astray. And what is typically a fairly automated process, but there are like non-automated functionality that you have to have that human component there
Sure.
to be able to monitor and adjust things as the process is ongoing. So like a coal facility, you have to monitor like effluent gases and things of that nature. Make sure you're not going over permitted limits and things of that nature. So you have that operator component that will monitor that. And if you start butting up against a certain limit or something, they can dial back certain things. So that's part of that operational aspect from a control room operator perspective.
Sure. I was trying to understand the concept. I wasn't sure if you were talking about operator as the factory or power plant as a whole, the person operating the power or the company, or if you're talking about an individual person monitoring things. So thank you.
Yeah. No, there's certain different aspects out there, right? So you got SCADA systems, all that, but yeah, I digress.
I agree with Tyler's definition of OT there. Really with the parallels to IT, where IT, like you see, like the output of any IT system is usually something that you're going to see on a screen. Either your application's going to work, you're going to get access to something, you're going to be able to log in somewhere, but it's going to be very screen-based. Whereas in OT, the output of computation is usually an action in our physical world. Being that I work inside the research lab, I don't get to see these devices out in the wild as much. It's more like I'm putting them into a zoo and they stay in their cage and they do exactly what I want. But I would say it's definitely like you definitely know when you're working on an OT system, when to set the IP address of a device, you have to use a wrench. And I think that, yeah, right. I mean, that's the kind of stuff you see in OT. Like you'll see dip switches, or you'll see dials and stuff like that built into the devices. It's really like computers for like electricians and stuff like that. It's a real different type of technology.
Yeah. I always found I agree with these definitions. I always found the interesting space where there's that sort of transition space, the network switches and all of this other infrastructure that's required for these specific devices that are interacting with the physical world to be able to interact with each other appropriately. You'd find them both in the IT space and the OT space. And I always found those interesting too. So I find the definition gets a little blurry when we get into those because, is this Cisco switch or other company switch? Is this an OT device or an IT device? And you really have to look at it in context, not in isolation. Let's think of a simple device like a printer, right? You've got it sitting right at the end of your desk. Is that printer an OT device?
Probably not.
Yeah, I think the answer is probably not. You're printing out your presentation you need to give to your manager the next day, or just notes from a meeting or something like that. Probably not a critical device. Now, what if that printer, same exact printer, is printing out calibration data for the things you're manufacturing as they come off the manufacturing line? Is it now an OT device? I think the answer is yes, because it's critical to the success of your manufacturing facility. If you can't print out that calibration data and include it with the packaging, you probably can't ship that product. So it's not a cut and dry thing for a device to be either an OT device or a not OT device. You have to take it in context, and that's where things get really fascinating to me. But even if we just talk on the hardware side of things, a basic desktop printer, we've just said it's probably not OT unless it's printing something specific to manufacturing. What if it's a whole office printer? What if it's the ones that can print and collate and do all those multifunction things that 40 people utilize? Is that an OT device? I think the answer is still no. I think there's a timeliness and criticality aspect that we've been talking about. What happens if that device is a printing press, a giant printer that is printing off, magazines? I believe that would be an OT device. But I need to figure out where's the threshold? What's different between that printer that's in the office that can print out, thousands of copies and that printing press? What's the difference?
Well, I mean, I think you're kind of getting at it when you're, sort of looking at the TLOS, the end that it is being operated toward, right? Because, if it's just, printing out, the occasional email and the occasional silly photo and, business documentation, all the usual things that you would expect an office printer to print out. Well, it's it exists to support the operations of the office, which in most cases is in the IT realm, right? If it's printing out, though, configurations, it's printing out production reporting, then it's being utilized to support the operation of some kind of process within some kind of industry. And that was sort of one of the, when I was, again, like reading some of these things from like Cisco and Red Hat and Palo Alto and just other sources of, trying to opine on what is the difference between IT and OT. One thing that kind of kept popping up again is that OT, which is kind of a blanket term, right? It can cover ICS, DCS, supervisory control and data acquisition, SCADA. And I mean, all of those systems exist to monitor and to automate industrial operations, whatever those might be, usually in real time or quasi real time. And OT really is, sort of that. I think Palo Alto used the word integration of hardware and software to effect that management and monitoring and automation of industrial operations. It's, the cloud of devices and programs that serve the purpose of controlling and monitoring and interacting with and programming the different devices that are used in industry and, actually defining and controlling and regulating and shifting the processes that are the production, whatever the production is, right? Whether it's a pulp mill or a paper mill or, a power plant, refinery, whatever the case may be. It's that cloud of stuff, hardware, software, that enables the effective monitoring and controlling and manipulation of that entire process environment, whatever it is. Which, so when we talk about things like IT and OT integration, right? I mean, a lot of the times that can mean two things, but I think it's maybe better to separate out, the idea of integration from convergence, because those are two different things. Integration means that you can use a lot of things like, say, a desktop printer in both realms and to serve both ends, right? You can use a desktop printer to serve the needs of your front office, and you can use that same desktop printer to serve the needs of your production floor. And, is it the same printer? Absolutely. But yeah, one is being used in an IT capacity, one's being used in an OT capacity.
Yeah, I'd like to expand on that a little bit too. So you got a lot of parallels. So I'll even extrapolate that some more. You have a lot of more recent parallels as far as, OT equipment out there, because, there's a lot of times where, at one point in time, this was like largely analog or, relays and things of that nature, a lot of hardwired devices for controlling a lot of these components. So as we've continued to evolve into more electromechanical style devices and more intelligence built into them, you get into computerized components that are out there that's like, oh my gosh, we can now serially connect them and have all this data come out of it through the serial connection at 9600 baud and all this other good stuff. So it's been an evolution out there. So we've finally gotten to kind of the tipping point where you have a lot of large convergence, and they talk about this, the convergence of OT and IT, because there's a lot of large parallels to the same style of equipment that you would use in the IT space on the OT space as well.
Yeah, one of the biggest deltas, comparing IT cybersecurity professionals with OT, is that in the IT world, they seem to be more siloed into that space, whereas in OT, we cross over fairly frequently into the IT space. And from my experience, one of the biggest deltas I've seen is how on the IT security, there's more focus on protecting data confidentiality, privacy, similar to what Tyler mentioned when he was breaking down his definition of it. While in OT, there's always, even though there's focus on those that I mentioned, there's a priority in also keeping these processes running safely and reliably. And that's a line we're constantly flirting with, right? How do we secure these systems, but still operations being so important from a business side and that's one of the biggest the concerns that the customers tend to bring more frequently. Any thoughts on that?
Well, that was actually a huge topic on our first episode where, you have the CIA triad of the confidentiality, integrity, and availability. Whereas, we kind of flip that dynamic, and its availability is like king on the OT side. And then you go down in integrity and then confidentiality, because a lot of these systems are very localized. So you're not really concerned about the confidentiality of it, but you're concerned about the availability and the integrity of it. Absolutely, all the way through.
Yeah. And again, you're right. We did talk about that like in the previous episode, but I think maybe for me, like coming back to what you had talked about, Tyler, and then Andrew as well, is, but just thinking like on my own experiences with OT, and Tyler, you really got at this, I think, with your explanation, is that, IT is essentially just mostly about the electronic world, but OT really is it's about where the digital touches the physical. I mean, we could say analog, digital, and to be fair, like the whole concept of digital analog interface is a core component of almost any OT system, because at some point, those digital signals hit some kind of device that is then going to be manipulating voltage on a wire. And that voltage on a wire might assume, one of a couple of discrete values, or it might cover, every step of voltage in the range. And then at the end of that wire, there's something, whether it's a pump, whether it's a valve, and it is not going to have discrete states. I mean, in theory, a block valve, you either want it fully open or fully closed, but any valve is not going to have just those two discrete states. A valve is going to be partially open, partially closed. There's going to be a transition state that comes up. Pumps can adjust the pressure that they are putting down a line. Motors can assume variable speeds, right? Different RPMs depending on need and demand. So, all of that lovely, happy digital stuff suddenly becomes real world and analog and very, very variable. And I mean, that's where the big challenges come from, because, if those things, and again, we discussed some of this with regard to like Stuxnet in the first episode, if those things go a little too far out of their normal range and their normal tolerances, then, those real world processes can start to generate real world smoke. And that's not a good thing either.
That makes a lot of sense. Now, is there a timeliness element to this? For instance, you mentioned that it's the devices that are used to monitor and configure. Now, in a manufacturing sense, there's an engineering team, and the engineering team is using their computers to design new versions of the widget you're making, and then their designs are then used to reconfigure what's happening in manufacturing for the next generation of the widget. I don't think we would call those engineering workstations OT devices. So I think there needs to be some sort of a timeliness element to this. It needs to be the loop must be not in order of weeks or months or years, which is the engineering time loop. It needs to be talking about like real-time or semi-real-time monitoring and control to get into the OT realm.
I mean, we have an issue there with terminology though, right? Because
sure,
when we talk about, an engineering workstation, yeah, we could mean something on the front end where they have CAD installed and they're, tweaking the design for a widget. But
right, and that was
But going back to episode 1, we also use the term engineering workstation in a different context, which I think came up in the Stuxnet discussion, right? Because that was the whole thing about Stuxnet, is it inserted itself on what was essentially an engineering workstation, or typically termed as such, within an OT environment, which served the express purpose of being the home for the software used to configure the controllers hooked up to the high-speed motors.
Right.
Right. So, in that sense, it's an engineering workstation. What we would call an engineering workstation in that context is definitely an OT device, but that's a terminology problem, right? So, I would, if we're talking about something where they're pulling up the CAD diagrams for the widget and, like tweaking it and, maybe doing some like airflow modeling or whatever the case may be that they need to model to determine how effective a widget it is, I'd maybe call that a design workstation.
Sure.
Right.
probably a better term for it.
Right. And I guess that kind of gets us back to that CIA triangle too, because at the end of the day, what is the thing on the workstation that has CAD and has the designs and has all of the, materials testing and whatever other modeling? What is the thing that we need to worry about protecting most? We need to ensure that we're protecting the integrity of that data, and we need to ensure we're protecting the confidentiality of that data. We don't want anybody stealing our widget designs, nor do we want to lose our widget designs.
Right.
Right? If that station goes down for a day or two, that might be inconvenient, but as long as the widget designs are secure and backed up or otherwise still available, it's not the end of our world.
Right.
Right? Whereas, if this is, if we're talking about a workstation where the availability of that data, and sometimes it might be the same data. It might be a CAD file in each case, right? Because maybe, that's getting fed into a CNC machine.
Sure.
But now when it's the availability and still the integrity, but the availability becomes king because that data needs to now be fed into the process, and the process is actually, converting that data, that electronic file, that electronically stored information is now being converted into, by whatever means, something that's actually happening in the physical world. We are taking the CAD file that has the picture of our widget, and it's going through some wires and some controllers, and all of a sudden there's this spinning machine over here that is literally like polishing widgets out of blocks of metal. Now having that availability of that data is key, because if we don't have that data, well, then maybe all of a sudden our CNC program interrupts in the middle. And if the data integrity is not there, then maybe we make a bad widget. But either way, now I think we've crossed into what is arguably OT.
That makes a lot of sense. It almost sounds like a good general definition for OT would be devices where availability is the highest priority.
I just had a thought out there too. When you were talking about the real time, you've got real time processes that are out there too. So these things have to react in a certain, state. So like predictive relays, you're talking about 60 cycles on your electric grid. So they have to be very responsive in their capabilities of being able to respond for particular incidents on the wire.
Yep.
So you're talking about, the sub millisecond type of things that you're trying to react to or anything like that. Whereas, typical, and I'm not deflating anything on the IT side. I'm just saying that, these are very well, specific purpose style of devices that are built to provide specific apparatuses, whereas like the IT world is more general purpose computing type of things. You do have some more generalized things for like networking and the ASICs and everything like that are out there as well. But, typically on the OT side, you have a lot of like very specific devices that were built to achieve a very specific thing out there, and they're continuing to grow and all that good stuff. So it's like a real-time OS that is like monitoring that electricity line off of different signaling aspects for the voltage and the current that's coming off of it, and then sending out discrete signals to basically a circuit breaker, which is a mechanically linkaged switch. All it is, to be able to do protection on the like electrical grid.
Yep. Same ideas like, pressure relief valves, various, safety instrumented systems, SIS, that, monitor plant processes, often involving, pressurized steam or a big fireball or things of that nature, right? Things that are important to producing power, or, it could be a different mix of like toxic chemicals important to producing, whether that's pulp and paper or whether that's polyethylene glycol or, you name it. All of these things that are like so critical to what we kind of know as just, on our orderly day-to-day lives. There's a lot of intensely.
You're just making widgets out there.
Yeah, or just widgets, right? Like, to put in your can of Guinness, like whatever the case may be, all of these things, that we kind of almost just think, I turn the light switch on and hey, the light comes on. Cool. I'm happy. I'm not thinking about a bunch of natural gas on fire 100 kilometers away from me, creating steam to turn a generator, but that is happening. And There are, all kinds of, you want to be able to monitor those things. You want to be able to very quickly, like you say, shut those things down if there's anything that happens anywhere in that system that could endanger the physical hardware of the system, endanger the lives of the people working on the system. And they do need to be able to respond with that like sub-millisecond latency. And it very, it's that bridge between like, the digital, the computer over here, and the physical. I'm literally slamming that valve shut or forcing the valve open, depending on the situation. At the end of the day, to keep your process running, everything that is integral to that process needs to be online, which means availability. If your controller goes out, if your motor goes out, you have a problem. If your controller on the motor goes out, you might have a problem. Depends a little bit on its fail condition, fail open, fail closed, but, and sort of everything up the chain from there. Now, in some cases, which gets us back to that loss of view discussion, right? In some cases, you might be able to actually, as long as the motor is still turning and it has its program locked in, as long as there's no need to make any kind of changes for the next however long, you might actually be able to just let that run for a little bit while the controller power cycles and everything else, as long as the failure condition for the controller doesn't automatically bring the motor to a halt.
Right.
And similarly, if you lose view on it for a few minutes, as long as okay, well, the program's locked in and it doesn't need to change for an hour, so we can take 10 minutes to reboot this workstation. Okay. But yeah, if you're even having those conversations at all, you're probably in an OT realm of some kind.
Absolutely.
Right? Yeah. Versus like, oh shoot, like, the accountant's laptop blue screened and we have to reboot it.
Right.
That sucks if there's a report due in the next hour, but it's not, if the report's 15 minutes late, there may be some knock-on effects, that are kind of outside of our ability to perceive here. Maybe, okay, you're 15 minutes late filing that report. So, maybe there's an extra form you have to fill out for the stakeholders or something, right? Maybe your stock price dips a couple cents because you were a little bit late in posting your results or whatever the case may be. I don't really delve into the stock market.
Yeah.
And it's not that is not an impact. It's not that it's not a bad thing. But again, like, it's a different category of problem versus I don't have the data I need to keep this power plant running.
Potential injury or damage to health or happiness or all those sorts of things. Yeah.
Well, and safety as well, right? Yeah.
Absolutely.
Yeah. Any kind of instrumented system that exists to preserve life or preserve physical integrity, very arguably OT, because again, availability is king there. You really don't care if, your fire suppression system is confidential. You just care that it turns on.
Yep. So yeah, as you look at each device around you, if you were to say, okay, what's the most important thing? Is it confidentiality, integrity, or availability? If you look at that device and say, this needs to be available beyond all else. All the other things might be very important as well, but if availability is king, it is probably an OT device.
And to paint a quick perspective also on the sensitivity of some of these control systems, I'll name one quick one. Was working back in LA, and when we were doing some network hardening on a power plant, there was a failed load, and it created it tripped a turbine, which is one of the biggest nightmares for anyone in the OT space securing power generation sites. And in order to protect all of the assets for that specific customer or operator, it created a chain reaction. So in order to protect their physical hardware, it has a system in place to trip the other sites that are nearby. So again, just painting a perspective of how dangerous sometimes working on these systems can be and the impact it may have. I think that incident itself led about 250,000 people with no electricity until those systems were brought back up. So just to paint a perspective there on how, sensitive and high stress working on these operating environments can be.
Unscheduled black plant.
Yeah.
The famous
bad topic.
I know, the famous zero megawatt club, the club no one wants to be in.
Yeah. Yep. And again, a lot of issues we talked about in the first episode, right? If you have a loss of view event, are you under requirement to shut down? Are you going to be able to maintain control of the process if you don't have someone who can have, a hand on the numbers for 15, 20 minutes? All of these interfaces between, what you see on a screen and what's literally happening physically in the world somewhere, often close by, sometimes not so close by. And it is all just like, a lot of it is just very finicky and very sensitive. And I mean, sometimes that's an accident of design and sometimes it's a very deliberate part of the design. But the end result is it does make, working in OT environments incredibly challenging, incredibly sensitive. And it does just seem strange to, come across from an IT environment where, I mean, not that IT environments are, completely forgiving of these things, right? I mean, there's lots of situations where you don't want a production server to come down. If Amazon US 1 West goes down, a lot of the continent is going to have a bad day. That is true. And even within, an individual company, if you lose, certain critical servers, maybe your billing system's offline for a while. Maybe your records keeping offline is for a while. Maybe some other aspect of, your day-to-day business operations are affected. And that's not good either. But it's not really the same category as literally having to shut off 2,000 megawatts of power generation for however many hours it takes to cycle the whole system and reheat the boilers and bring it all back up. And the impacts are much further reaching probably in that latter case because, again, it sucks for you as a business if some aspect of your business operations goes offline. But if the operations that are offline are providing power to 750,000 people, the sense of scale is wildly different. And I mean, we do usually think of operational technology, OT, as being the province of industrial environments. And certainly if you, Google or Bing it and look for, what is OT, you will tend to see that the discussion gets centered on operational environments, process environments, industry. And to be fair, that's where most of it is, but not necessarily, again, it's, one of those terminology things, right? Is the HVAC system for a building industrial? We probably don't think of it as such, but that is an operational technology system, right? Are the X-ray machines at a hospital an industrial system? I mean, they certainly have what we might call industrial scale, but we wouldn't necessarily think of them in the same category as a paper machine or a boiler. But arguably, those are an OT environment as well.
Well, that's actually a really interesting example. The X-ray machine, I'm not sure from the definition I posited here, the availability is most important. I'm not sure. Obviously, we want the X-ray machine to be available, but I think even more important than availability on an X-ray machine is integrity. It has to operate correctly whenever you operate it. So that sort of pushes against the definition we just created, because if that X-ray machine operates incorrectly, that's even worse.
That's true. And it's kind of weird because all the different articles I read, trying to narrow down how people define OT a lot of times, and it does kind of break along the lines of confidentiality versus availability. IT tends to be concerned about data confidentiality. OT tends to be concerned about data and equipment availability. Yep. Where is integrity in that? Well, integrity is kind of on both sides of the line. I guess it depends on, I guess we have to, do some failure analysis on the X-ray machine, right? I mean, obviously, if the X-ray machine, what is the failure condition of the X-ray, or what is the failure that we're dealing with on the X-ray side, right? Is it putting out way too much X-ray? Well, that could be harmful to people, right? In addition to producing incorrect imaging, that could actually be harmful to the patient. If it's not putting out enough X-rays, well, that is impacting imaging, which has the knock-on effect of, impacting the patient, right? If we can't see clearly where the fracture is on the bone, how do we know how to deal with it?
Right.
So it is a good point, but I would still tend, I think, to think of that hospital equipment as being a form of OT because availability still is fairly important to it. And I mean, maybe we could step beyond the X-ray machine and just go to, like the mobile works, the mobile workstations that are heart-lung machine, or even just like the mobile patient care workstations that a lot of clinical and nursing staff use these days, right? Like those things need to be operational so you can access pertinent patient data in a timely fashion. And I mean, you would hopefully have that, there is a confidentiality concern there. So this is maybe where we get to the IT-OT convergence. Maybe it's the strongest example is in healthcare, because obviously you care about like patient privacy, confidentiality of patient data. But, we've seen the case of like ransomware attacks against hospitals limiting the availability of patient data. And that's a huge concern, and it becomes a huge concern very, very quickly. Especially for patients who are, in ICU or in trauma care, and oh shoot, I can't look at, I don't.
What's their medical history?
Yeah. What's their medical history? What are this person's
blood
drug
type
interactions, blood type, right? All of this, they're unconscious. They can't tell me any of it. And a lot of that data does need to be delivered in near real time.
Yeah.
So I do agree that the lines blur. I think if it were me making the call, I would probably say that, a lot of that stuff in hospitals still probably falls more on the OT side than on the IT side. Again, just because of the need for that, the availability, the potential harm to human life in the absence of availability, and the need for real-time or quasi-real-time access to the data.
I think that makes a lot of sense. I think availability is still probably the most important thing for defining an OT device. But yeah, boy, that's just an interesting thought, talking about an X-ray machine or other medical equipment. X-ray machine is one of those things on the cusp, but then the heart-lung machine, that's like, no, it better work as long as we need it, as soon as we need it. So that's definitely what qualifies an OT device.
Yeah, and I mean, you can wander elsewhere into the hospital or elsewhere down the chain of devices in the hospital, right, and get a little bit closer to the patient. Well, what's the patient hooked up to, right? Probably a heart rate monitor, pulse oximeter, essentially real-time monitoring of, vital body statistics. Could argue that's an OT device. Now, that might be, that unit might not even be online in the sense that it's connected to a network. I imagine many of them are, but not necessarily all of them. Right? Some of them are just local to the patient. They just live on a pole by the patient's bedside. There's no cabling other than what's going to the little pulse oximeter sensor or to the blood pressure cuff. And everything is just recorded on box. And I mean, from a, how do I defend this perspective? Cool, great. That particular device is as robust as it's going to be because it's not connected to anything other than itself and the patient. Is it still an OT device? I would argue that it fits the definition for an OT device. It's just not a connected OT device. So, if you're trying to devise a cybersecurity strategy, then it's like, okay, well, we know we have those devices out there, but they're literally never hooked up, so don't need to worry about them. Except, to make sure that only people who should have physical access to them have access to them.
Yep. The physical access is definitely one of those things to take into account.
Yes. But, in other cases, I mean, those, the workstations that the nurses need to move around, they're going to need network access. They're going to need to be able to pull up patient data from different points and then from different workstations. Arguably, some of the bigger stuff that, the heart-lung machine, maybe not necessarily the portable ones, but, the larger ones, the MRI devices, the X-ray devices, a lot of those, there's a demand now, I think, for network connectivity, because again, that information doesn't just need to stay locally within the machine or the, just the computer that's hooked up to it. That needs to then be able to be added to the patient's files, sent to the doctors, all the rest of that. And again, there is still the confidentiality concern, which puts it, which tips us towards the IT side. But again, it's that data availability, making sure that I can actually get at all of the pertinent information about the patient that I need when I need it. I think kind of, that tips us back towards the OT side. So maybe that's like, maybe healthcare is like converged. Like when we're talking about convergence, maybe that's what healthcare is.
Yeah. The more we talk about this, the more more my respect for everybody that works in the healthcare, IT, OT, and obviously everybody, doctors, nurses, and everybody, just that is a unique and very, very challenging space be in, and I definitely have to respect all of them.
Yep. It's, keeps you on your toes, definitely.
I can't even imagine what a normal day is versus even an abnormal day.
Yeah. Yep. So
we've been talking, you mentioned a little bit when we were talking about hospitals, the physical access to these devices. I don't think it's pertinent necessarily for this discussion, but we should definitely talk about, from a security standpoint, there's all sorts of factors, not just, do we have a firewall? Do we have the latest updates? There's like physical access. There's lots of interesting aspects that we can explore over there too.
Yeah. I mean, I guess it's worth, on that, it is worth noting that usually it is characteristic of an OT environment for things to be a bit more isolated, and not just electronically, but also typically physically. That's not necessarily to say that they are under lock and key. Often they are not, but it's, usually not, it's not the same as walking into an office and, it's just rows and rows of desks with computers on them. That tends not to be how OT works. There's, so in that cabinet over there, there's a switch there. And then underneath that boiler over there, there's a little controller shed. And inside there's a cabinet and there's another switch in there. And there's also a workstation. And like the physical locations of a lot of these things are they're more obscure. And that doesn't necessarily mean they're more secure, but they're definitely more obscure. They don't, sort of conform to what we tend to think of as being characteristic of an IT environment. Computers on desks. Yeah, there's a server room with everything nicely racked up. The printers in one convenient spot next to the coffee room and whatever else. The positioning of devices, the ability to access devices physically is a little bit more, shall we say, ad hoc. And the environment in which those devices are situated is not necessarily, as clean as we would typically expect an office environment to be.
Very true. Also, some of the OT devices are like monitoring pipelines where they are hundreds of miles potentially from any human.
Right, literally in a shack next to a bog with a solar panel on top.
Yep.
No, that's very true. Especially when you get into things like SCADA, right? Because, you're distributing control over a large geographic area at that point. And so, it literally is the case of like, we have, 6 block valves on this pipeline and there's a little shack, next to where each one is located. And that's where that's where the instrumentation is and the controller and there's a little HMI out there. It's like, so, and the last 2 are only accessible in wintertime because otherwise it's all like swampland and we actually have to like wait for it to freeze over to drive out there.
I hadn't heard that one before, but sounds like interesting.
That's not, well, and I mean, that's environment, like literally in the sense of like the natural environment in which a lot of these things operate, right? I mean, up here in Canada, northern Alberta, that's not uncommon. It's not to say that it's ridiculously common, but it's definitely not unheard of. I've worked for companies that have had sites like that. My sister works kind of in an oil field adjacent role, and she's, been in situations like that where, she has like, and in her case, sometimes, because she does like environmental sampling and stuff, in her case, sometimes it's even, more pressing and that, okay, well, we can go on site now because, we have the ice road, so we can get there. But, like it's March. So like you have, 2 weeks, unless the temperature goes above this, then you need to leave that day.
Wow.
Because otherwise it's a helicopter to get you out. And there's nowhere for the helicopter to land. They'll just drop a ladder.
Talk about availability being critical.
Yeah.
If this device failed, we can service it in 4 months.
Yeah. But we need it tomorrow. Okay, well, then it's a helicopter.
Wow.
And I mean, sometimes, that's the call that gets made, right? But that's a very expensive block valve service at that point.
Okay, do we want to try and circle back here and just come up with like our conclusion? I think we have sort of a core definition of OT. We've come about it in a bunch of different ways. What do we think what is OT? What is an OT device?
Like I say, I think I'm going to go with sort of where I was going at the a little bit ago there. Where it really is, it's that collection of hardware and software that is principally concerned with process availability, whether that's monitoring and controlling the different devices that affect the process, or providing safety oversight to keep the process within its safe parameters and bring it to a halt if it falls outside of those parameters. It really is just about that management and monitoring and automation of all of those different industrial operations in real time or near real time, to monitor and control whatever the core processes are for any particular industry. That's my definition.
I think it's a great definition. I can't disagree with that at all. That's that feels like where we've been heading this whole time, and it's interesting because devices can be, it can be a standard IT device, but it's in an OT world, and thus it becomes OT covered, part of the OT world. So yeah, it's a really interesting world to work in.
Yeah. Well, and I mean, I think it's a good definition because it really is focusing on what the devices are used for, right? I mean, right. Not that I'm probably never going to see, your average, PLC. You're not usually going to see those in an IT environment. There are some types of devices out there definitely that are, this is more or less the province of OT. This is more or less an OT specific device, but it really does come down to, and I think that's why I like that definition that I offered, is that it really comes down to a usage focus, not a device type focus. It's what, and which we got, which we touched on earlier, talking about the printers. What am I using this thing for? Because some stuff I'm really only ever likely to see in an OT environment. Your typical Windows workstation, well, I can see that anywhere. Your typical, printer, I can see that anywhere. But what am I using it for?
Yeah. Context. The context of the device is really important.
Cool. Well, unfortunately, we've lost most of the rest of the discussion group. But, apart from that definition, I don't know. You got any other closing thoughts, Lance?
Well, I really like that definition. I think it's really important to pay attention to the context more than just the name or title of the device or even the label of the device. And this has caused me to reflect even around my house, the connected garage door opener I have is like, wait a second, that's probably not an IT device anymore. So it's caused me to do a lot of internal reflection on just my surroundings and trying to categorize things. And that's just been fascinating. So thank you very much for the mental exploration there.
Oh, happy to. See, and this is why I try to not have anything critical to my house's operations have network connectivity.
I'm gonna go cut that wire right now.
Yeah. It's like, hey, do you want to switch to our services? It comes with a free Nest thermostat. Let me stop you right there. That is the last thing I want. Okay, cool. Well, hopefully, after all that discussion, we've come away with a good definition of what OT is. If you agree or disagree, by all means, feel free to reach out to us on LinkedIn. You can either reach out to Verve directly on LinkedIn or to myself. My profile will be in the show notes as well. Happy to hear from you either way. If you have any additional thoughts you'd like to share on what OT is, we would be happy to hear them. Might even find a way to incorporate them into a future show. But until next time, thank you for listening, and we will talk to you again soon.